Alright, so this is part 2 of stats review, and, yeah, what we're going to talk about today is about residuals and, dots. So what is residuals? Let's just, anyways, let's just, broadly go over it, like, let's get this arrow out. Alright, so, usually what you want to do to get, like, a straight line, a mean line for all these dots, is just draw a straight line through, correct? Just like draw an arrow. Whoa, that was so wrong. An arrow like that. Make it red. Oh, my League of Legends is on. Wait up. Gotta turn that off. I was just watching one of my friends play. But yeah. So what you want to do is wherever you find the most dots, place it there. And like you could just keep on doing that over and over again. Put it right here. But sometimes there's a positive correlation, there's a positive way. It's almost like that. And then, I mean, the better, the way you define better, like, is, crap, I'm just like not speaking well right now. I need to play some late. But the better, the closer the dots are to this mean line, or the residual line, the better. Because you want more of a straight data, more of a accurate data. These dots show how far apart, the distance between the dot and the line, the distance between the dot and the mean line is your correlation, how accurate your data should be. These dots are observed, and the residual should be the expected. The mean line, the red line, should be the expected. So this correlation is 0.99, while the other ones, this one is close to 0. I mean, there's also positive correlations like that, and negative correlations. It just depends on what you are talking about. So yeah, just find the dots, find the middle line of the dot, and place the line there. Just draw it through, draw it through, draw it through, draw it through. Alright, and the closer the dots to the mean line, the better, or the more accurate. So what we're gonna see, the distance between the dot and the mean line should be at a 90-degree angle. So let's pretend we want this dot. So we draw a 90-degree angle to there. Just make it red again. Alright, it should be about 90 degrees. If not, it's fine. Yeah, so, oh, that was way off. Yeah, so if you see the distance between this dot and the mean line, that's how far away the correlation is, or the R value. And there's a lot of calculations. You just have to find the mean of all R values to get the actual mean R value. So yeah, this is a residual plot again, just with the line going through it. So the distance between the red dots and the blue mean line, the residual line, is what you would see like this, just like that. The positive correlation, just like that. And for me, it's easier to see residuals when they are horizontal. So I'll just turn this like that and see how horizontal. Just bear with me. Like ignore the outside of the graph. Just look at this line. So you can see there are some dots above, which is above the correlation line, the residual line, and there are some dots below the residual line, and like that means there are up and downs for this for these data points. And I mean, I guess that these are really close, because you see it almost, these dots almost form a line, just except for these dots. All right, I'll just turn this straight back up. So for residual testings, they always ask what's the r squared, what's the slope of the residual. Well, first you need to find if it's straight enough. This is called the straight enough condition. It's awesome. I just love the name. This is to determine whether it looks straight or some other lines look curved, like a parabola. Oh no, not a parabola. Exponential graph. It would just look like that, and that would not be straight enough. We need something that looks pretty straight. I mean, these are okay. Like the first two are okay. They sort of pass straight enough, as long as they're not widening like a vase or a V. As long as they're not widening, that's straight enough. And there's also an outlier condition where, like, some graphs like have dots in the middle of nowhere, like right here. So pretend you see lots of dots on the, like, really close, and you see this freaking outlier. I just choked. You see the outlier just right here, and you're like, what is that? What does that have to do with anything? What? See how far it is away? That's really far. So you have to draw the 90 degrees. I'm gonna show you again. This is how you see if it's an outlier. Draw the 90 degrees, and you see how far it is. And if we were to compare it to a regular, this dot, 90 degrees it's a pretty big outlier. That's a really big outlier, and you can't really have outliers in the residuals, or it would screw all your data up. It would make your line look like this. It would influence, the outlier would influence the correlation line big time. Okay, so when you're done stating out the conditions, just state them out. It's really easy. You should. They're probably going to ask what the slope is, or the equation of the correlation line. And what you want to do is just the regular y equals mx plus b, or y equals slope x plus the y-intercept. And I think there should be some other stuff. Yeah. So it's going to be y equals b naught plus b1x. So the b, like the b, then small 0, b then 0, is the y-intercept, which should be down here, and the b1 should equal to the slope. Alright, and you just plug it in, and you should be good. That's how you would find your equation. And also a commonly questioned thing is the r squared. I mean, I have a hard time explaining it, but it's pretty much the variability of how it's like an overall measure of how successful the regression line is linearly relating to the y to x ratio. And it's like, the higher the r squared, the better, because your r is this. The closer your r squared to 1, the better, because this is not good. You would subtract like a really big number from a small, like the smallest number, and the variability would be way off. So the closer to the closer for your r squared and your r values to 1, the better. Alright, I hope I explained it well. I'm just really tired right now. I'll see you guys later.